In today's lesson, we are going to have a look at right angle triangles again, but in this case, we're going to have a look at how we're going to find some missing angles inside a right angle triangle, right? So obviously, I hope you have watched the video on finding side lengths that I did earlier. Obviously, we looked at all the three trigonometric ratios dealing with right angle triangles, and obviously, we talked about the easiest way to remember them in the form of SOHCAHTOA. So sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Right, so we're going to use these three trigonometric ratios to find some missing angles in right angle triangles. So let's jump into the very first example today. So like we did for finding side lengths, the first step is obviously to label the sides of the right angle triangle. The side opposite to my right angle is the hypotenuse. In this question, we're trying to find theta. So that's the given angle in this case, and the side opposite to that will be our opposite side. And finally, the third side is going to be the adjacent side. So we have been given the side lengths for opposite and hypotenuse, and obviously the ratio that deals with opposite and hypotenuse is the sine ratio. So I'm going to write that down first. The sine theta equals opposite over hypotenuse, right? And I'm going to substitute the values as sine theta equals the opposite side is 1 and the hypotenuse is 2, right? So we know that sine theta equals a half now. The way we work out theta is what we call as the inverse, right? So what we mean by that is theta equals sine inverse of a half, right? Now I'm going to go straight to my calculator. I'm going to show you how to do that on your calculator, right? So I've got a TI Inspire CAS calculator here. I am opening up a calculator page, right? Now, like we talked about side lengths, the calculator settings needs to be in degrees. And obviously, as you can see, my calculator is in terms of radians at the moment. So I'm going to first go ahead and change that. So menu settings, document settings, I've changed to my angle to degrees. Right, now that I've done that, I'm going to go select my trig option. Now for side lengths, we had a look at the top row for finding the size of an angle. We are going to have a look at the second row, which is where the inverses are. So obviously we have to select sine inverse, right? And inside the bracket, we're going to enter the half, which was in the question, right? Control enter. That gives us the value for the angle that we're dealing with in this question equals 30 degrees. So the answer for theta is equal to 30 degrees. Right, looking at the second example, and again, we're going to start by labeling the sides. The hypotenuse is the side opposite to my right angle. Right, theta is the given angle, and that's going to be my opposite side, and the third side is going to be my adjacent side. Right, in this case, the two side lengths we have are adjacent and hypotenuse, and the ratio that deals with the adjacent and hypotenuse is the cosine ratio. So I'm going to write that down like we did in the previous example. Cos theta equals adjacent over hypotenuse. Next step is substitution. So cos theta equals 1.5 over 2.5. Right, and now we're going to go into a calculator because what we have to do now is we're going to do the cos inverse of 1.5 over 2.5. So I'm going to go to my calculator again. Right, so we select the trig option, and this time I'm going to select the cos inverse. Right, so 1.5 over 2.5. Control enter. Right, so 53.13 degrees. Now, sometimes the question might say, write your answer correct to the nearest degrees, which would be 53 degrees in that case. All right, so those are two straightforward questions. We label the sides, we pick the ratio, we substitute, and then we solve for the missing angle. Right, now here's another example. This time, unlike the previous two examples, we actually don't have a diagram, right? And that's why I've said the difficulty level is probably somewhere between medium and hard, right? So let's read the question. A diagonal cut of length 2.85 meters is to be made on a rectangular wooden slab from one corner to another, right? So obviously, let's underline the important bit. So diagonal cut of 2.85 meters, right, is made on a rectangular wooden slab from one corner to another. The front of the slab measures 1.94 meters. Calculate the angle. So the front of the slab measures 1.94 meters. They want us to find an angle with the front edge at which the carpenter needs to begin the cut. So let's draw a diagram. So obviously we have a rectangular wooden slab. So I'm going to start by drawing a rectangle, right? So they want to make a diagonal cut. So I'm assuming they're going to make a cut across the diagonal, right? And the diagonal cut is of a length of 2.85 meters. So that gives me that length here is equal to 2.85 meters. And obviously because it is a rectangle, those are going to be right angles or four corners. The front of the slab measures 1.94 meters, right? So to me, that's the front of the slab. So that's going to be 1.94 meters. We want to calculate the angle with the front edge at which the carpenter needs to begin the cut. So the angle that they need to make the cut is right there. So the angle is going to, let's call that theta, right? Now, this is the hardest part of the question. Obviously, we have to read the sentences and we have to bring up a diagram before we get on to solving for the missing angle, right? Now we've done the harder bit. The easiest bit is what we did in the previous two examples. Label the sides. So that's my right angle. So 2.85 is going to be my hypotenuse. I'm trying to find theta, so that's going to be my opposite side. And 1.94 is going to be my adjacent side. Right, so the two side lengths we have now are adjacent and hypotenuse. So we're going to go ahead and pick the cosine ratio again. So I'm going to write that down. Cosine theta equals adjacent over hypotenuse. Substitution, so cos theta equals 1.94 over 2.85, right? And to find theta, we've got to do cos inverse of that fraction. So 1.94 over 2.85. Right, so going back to my CAS calculator, right click button, and I'm selecting my cosine ratio. Right, so control divide. So the values are 1 point. I'm just going to go back and check that again. 1.94 and 2.85. So 1.94 over 2.85. Control enter. Right, gives me the answer as a decimal, so 47.10. So the question wants us to 1 decimal places, right? So theta equals 49.1 degrees. So in other words, the carpenter needs to make a cut along the front edge with an angle of 49.1 degrees to achieve the required diagonal cut. Right, thank you for listening, guys, and have a wonderful day.